very slowly.
Okay.
All right, so 1A.5 exponential functions and percent change. So we're going to analyze. So we have here, Sadie collected 10 pounds of apples at an apple orchard. She is determined to eat 20% of the apples remaining every day after the day she went to the orchard. Write an exponential function to model the scenario and use it to estimate how many pounds of apples she has after 1 week. Okay, so the first thing we're going to do, the whole purpose of your car practice was to kind of get you used to breaking down a problem, reading, analyzing. However, we're not spending 40 minutes on one problem today. So we're going to talk about what you should be pulling from here. I know that she collected 10 pounds and she is determined to eat 20%. I'm eating 20% of the apples every day until I'm pretty much gone, probably. She doesn't want any apples to go to waste. So when I'm looking and thinking about what's taking place, I have my X, which is going to equal my days. I have my Y, which is going to equal my pounds of apples. Does that make sense? Yes? Those are the two things that I'm comparing. Those are my quantities, correct? So on day 0, how many pounds of apples did she have? 10 pounds of apples. And she's eating 20 pounds of apples every day. Between our examples we've had so far with the depreciation, car depreciation, with the car appreciation from yesterday, how would I calculate how many pounds of apples she would have left on the first day? No, what do I multiply by?
20%.
I'm not multiplying by 0.2. What does she have left? If I'm eating 20%, what do I have left?
80%.
80%. So what am I multiplying by? 0.8. Remember we talked about with the car is maintaining value, right? I may be losing, but what am I maintaining? So 10 on day 1, what I have left would be 10 times 0.8. And 10 times 0.8 is 8, right? This pattern would keep going and going and going because I want to know how many pounds do I have on the 7th day. Would I want to keep going down this over and over? No, that's the whole purpose of a function. A function is so that I'm not repeatedly doing something that there's a pattern for. Does that make sense? So there's a pattern for this, and that's our exponential model. Y equals A times B to the X. Anytime I am repeatedly multiplying the same value, that is an exponential situation. Because every single time, every day, I'm multiplying by 0.8, correct? So for this problem, our A, that's going to be our initial. Your initial is when X equals 0. Remember, we're not using regressions. We're not editing. We're not doing that. We're doing it completely by hand. Got it? Your B is your growth or decay factor. How do I know which it is? Are you adding or are you subtracting, right? If it's a growth, then I'm going to be adding. If it's a decay, I'm going to be subtracting. So essentially what your B equals mathematically is B equals 100% plus or minus your percent change. Okay, that's what your B equals. So your B equals 100% plus or minus your percent change. That's why for this problem, ours is 100%. And because I'm eating 20% of the apples, I'm losing 20%, right? And what am I left with? 80%. 80% is 0.8, correct? So my percent change is 20%. Does that make sense? All right. So I have my A, I have my B. What is my A?
10 apples.
10 apples. A is my 10. That's because that's the value at 0. Yes? So can I write a function model now? Yeah, I only need to know 2 things, A and B. And do I know A and B? So f of x equals, what's my A? What's my B? To the x. That's a 7.
Oh.
So could I calculate how many apples or pounds of apples she would have left after 7 days now without making a chart of me repeatedly multiplying? Yes? How do I do that? I'm going to plug it in. So to find at 7, this is going to equal 10 times 0.8 to the 7. So I'm going to go to my handy dandy calculator. Turn on Sylvie. I'm going to clear her. And I'm putting in 10 parentheses 8/10 to the 7. So after 7 days, how many pounds of apples is she still working with? That? She's working with approximately 2.097. If you're not good at rounding, what did we talk about doing? Anyone remember?
5 and up is 8.
If you're not comfortable, how can I make the calculator round for me? Mode.
Change.
There we go. We can make it float and round for us. So if rounding isn't your strong suit, you can go to mode 3 and it will round for you. Does that make sense? So she has about 2.097 pounds of apples left. I don't have any room to write it, so I'm going to write it right here. 2.097 pounds remaining. Was it terrible? No, was it? Not at all. Okay, as long as I have my A and my B, I can write the expression. Make sense? Okay. All right. So you're about to do a group do. On your group do, you're going to read through. You are given the equation and you're going to analyze the equation. Does that make sense? You're not trying to find it. You're breaking it apart. Yes? All right. Go. Talk to your group. Read through and then talk. Okay. As I walked around, I see people thinking and talking, and I like it. Let's try to bring it back together. So we have P of T equals 3 times 1 and 25/100 to the T, correct? So right off the bat, I know that 3 is in the place of my A, and 1.25 is in the place of my B. Agree? Okay. Each piece has a role, correct? A's job is, it's your what? A is your initial. So A is my initial value. So what is my initial here? There's 3 people. A is, so this is 3 people is where it started. So 3 sick people started the cold. Does that make sense? Okay. After that, you now are on to your next question. It says, what is the growth factor? Well, B is my growth factor. Right? B is my growth factor. What is the value of B? 1.25. That's my growth factor. Yes? So that's what I'm repeatedly multiplying by. Does that make sense? Okay. Oh, guys, my kid's calling me. Yes. Okay, here we go. 1.25 is our growth factor, correct? All right, your percent change. Remember how over here we talked about your B equals 100% plus or minus your percent change? Okay, so when we look at 1.25, well, 1.25, that means I'm at 125%, correct? So 125% equals 100% plus something. And what is that plus? 25%. So my percent changes 25%. Does that make sense? So my percent, this is my percent change. Okay, your percent change is going to be how much are you above or below 100%. Do we see that? Looking at the math we did, does any of it look complicated? No, it's just literally a matter of you reading and identifying what's being given to you. Got it? Yes? All right. Ready to keep going? All right, here we go. So here we have Rohiza sold her stamp collection, and every year thereafter donates 30% of the remainder of this money to charity. If her stamp collection sold for $6,000, how much of the initial amount will she have left after 2 years? Okay. This way, it did not ask us directly for a function, but because it says left after a variable amount, that means what is our function? Okay. It did not say find the function, but because it gave us a variable instead of a numerical value, we know we have to find a function. Does that make sense? So from this problem, we're going to identify what's our A and our B, because we're writing y equals A times B to the X. Got it? All right, so beginning, what is my A?
30%.
Is what?
6,000.
It's 6,000. Why is it 6,000? It's her starter, what she started, what she made. I don't know what kind of stamps she had, but she must have had some real nice stamps. That's a lot of money for some paper with sticky stuff on it. Okay. So we have A equals 6,000. Next, we got to find our B. Your B equals 100% plus or minus a value. What am I doing here? I'm subtracting. Why am I subtracting? She's donating because she is donating 30%. That it's going to be a minus 30%. Does that make sense? So minus 30%. What is my B? 70%. And how do I write that as a decimal? 0.7. Do I have all I need to write my function? Yes. So it asks us to put it in terms of t. So instead of f of x, we write f of t equals 6,000 times 0.7 to the t. Yay, nay? Okay, the next one is going to be a student do. That means I want you to do as much as you possibly can without me or a peer. Got it? You're going to read it, you're going to decipher it, you're going to do it on your own. Okay, so Peter here. What was Peter's A? 45 likes, right? So our A equals 45. Agreed? All right. What was happening with this B? Was it a growth or a decay? A growth. So that means he's adding that 15%, right? Because it says increases by 15%. So plus 15%, which equals 115%. And as a decimal, that's going to be 1.15. Oh, yeah. I was going to let you come to that conclusion. Good job. All right. Can I write my function now? Yes. So we have f of x equals 45 times 1.15 to the x. Yes? All right. This is the part that people get stuck on. So his first day is his 0, right? So therefore, his 25th day would be what? It would be 24. Okay. He's not starting at 1. We call that his first day is our 0. So when I'm calculating, what would the 25th day of the month be? It would be f of 24 instead of f of 25. So that would give me 45 times 1.15 to the 24. So he would have how many likes roughly? 1,288 likes. So if he keeps growing, that's where he'll be. on the 25th day. Now, I've never had that many likes on a post, so I assume that's really good. Oh, I lie. I'm in this Target shopping group, and I like shared a post, and it got like 1,200 likes. It wasn't my original, but I did share it, and it got like 1,200. So I feel like that counts. So not to brag or anything.
Okay.
They like what I shared. Okay. All right. Here's your group one. So you can go back to talk to each other. Every time I read Dante, I think of the movie with the boy who goes into the thing, chasing after the grandpa, but it's not really his grandpa that plays the guitar. Yes, Coco, because the dog's name is Dante. Every time I read this, I'm like, oh, I think of dog. I'm like, oh, it's a dog though. All right, but we're trying to prove, is Dante right or wrong? So talk it out, read it out, and go. All right, so Dante is like, oh yeah, I'm gonna wait till week 4, and in week 4, it's gonna be free. Right? That's his thought. Oh yeah, free 99 coming in there. Was Dante right or wrong? Dante had the wrong concept. Instead of multiplying each week, Dante did what? He was subtracting, guys. He went 100 minus 0.25, 75 minus 0.25, 50 minus 0. He's like, oh, I got this. But that's not what's taking place. He's giving an additional percentage off, but he's not subtracting that amount. So that means that we have an A, and our A equals 100. Until we have our sale, you're paying a whole full price. Then B is 100% minus our percent change, which is 25%. So therefore, we're at 75% is our decay factor, which equals 0.75. So our function is f of x equals 100 times 0.75 to the x. Correct? So now we want to know, is it free at 4? So f of 4 equals, I'm going to go to my handy dandy calculator. This time I'm going to model it in the table because I want us to see how long it's going to actually take Dante to get stuff free. So we have 100 and to the x, right? So I'm going to go look at the table. At week 4, Dante is still paying roughly 32%. Yeah. Sorry, homeboy. I'm going to make it round to the perfect number so we can see it a little better. So week 4, he's paying 32%. And then as he keep going, how long is it going to take him for it to be free? It's going to take all the way to week 19.
Oh, you'll be fine.
I would believe that if they're going out of business or something, that by week 19, everything would be gone.
Why would you say that?
Everything would be gone. So week 4, it was still 32%. The actual answer is at 19 weeks, it would be free. So he was way off. He had to wait 4 more months than he thought. But like I said, nothing should be left by then, right? Nothing should be left by then. No, it goes in your notebook.